We are going to discuss the new topic called capacitance of the parallel plate capacitor. So let us first of all understand what is capacitor, why what it is used. Capacitor is a device which is used to store the energy. We all know that, right? So now we are going to calculate the electric field and the capacitance of the capacitor between the two plates. So this is the schematic diagram to understand the two parallel plate capacitor which are having a uniform electric field, and it has a area of cross section over here, area of cross section A, and this magnitude will be equal and opposite in direction. So now let us see the equation. E equal to sigma by epsilon naught. So sigma is the surface charge density. Sigma is surface charge density. Sigma is the surface charge density, and epsilon we know that is the allowing capacity of charge, the permeability of the free space. Suppose if D is very much smaller than the area of cross section, D is very much smaller than the area of cross section. Suppose D is very much smaller than the area of cross section, then we can use this equation, this result, for a finite sized parallel plate capacitor. So let's calculate the electric field. So the electric field between the capacitor E equal to sigma by epsilon naught, whereas sigma is equal to charge per unit area. Now E equal to sigma is Q by A into epsilon. So this is the electric field present between the two plates of the capacitor, that is Q divided by A epsilon naught. Since the electric field is uniform throughout the parallel capacitor, we can calculate the potential difference between the plate. That is V equal to the potential difference. The potential is given by V equal to E D. So we know that E, the value of E is equal to Q divided by A epsilon naught. So substitute this. So therefore Q divided by A epsilon naught into D. So this is the potential capacitor. Now this of the capacitor. C equal to Q by D. So this is the general equation for to determine the capacitance Q by D. So we know the value of V. So Q divided by V. So simplifying this, we will get Q will get cancelled. We will get C is equal to A epsilon naught divided by D. A epsilon naught divided by D, isn't it? So this is the capacitance of the parallel plate capacitor. From here we can understand that the capacitance is directly proportional to the area of the cross section of the capacitor, and it is also inversely proportional to the distance between the two plates of the capacitor, right? So this is the final equations. This is the equation. C is equal to A epsilon naught by D. So we can understand if you reduce the distance between the plate, then the potential difference between the plate will be decreased. As a result, the voltage difference between the terminal of the battery will be increased. So what happens? There will be a flow of additional charges from the voltage battery to the capacitor. So it will continuously flow the charges until both the voltages will be equal. So if similarly if we increase the distance between the two plates, if we increase the distance between the two plates, what happens?